Hello, I'm Bob Wolbert, Engineering Program Manager for the Elecraft PowerCombo. I'm discussing the Elecraft PowerCombo, which is what we call the KPA500 and KAT500 pair. The PowerCombo transforms your radio into a 500 plus watt transceiver. Together, this forms a system that gives you the extra capability of over 500 watts along with a wide matching range tuner that lets you feed power into just about anything. The station integration provided by the PowerCombo means that you can click on a DX spot and immediately call, with a signal 7 dB stronger than your barefoot transceiver, and with no manual switching required. Not only are you fast into the pileup since you don't have to retune anything, but the extra power gets you successfully through it quickly. The PowerCombo gets you that new band country or higher contest rates, or at least more reliable communications for your rag chews through this nasty extended solar minimum. Remote station operation was a principal design consideration for the PowerCombo. As with most Elecraft equipment, operating firmware is field upgradable. New firmware adds new features and capabilities, so your gear gets better and better with time. The PowerCombo works with all modern transceivers. What we call basic mode relies on the internal frequency counter included in both devices. Basic mode requires no data connection to the driving transceiver at all. The frequency counter runs in the background, and when it detects that your transmit frequency has changed, it commands a change to the PowerCombo. This takes a short amount of time to implement, but only on your first transmission in a new frequency segment. Implementing enhanced mode informs the PowerCombo that you've QSY'd before you transmit, so there's no delay at all. It's enabled with data cables between the PowerCombo and your transceiver. Different manufacturers use different frequency reporting techniques. The PowerCombo supports data from Elecraft K3, K3S, and K4 via the aux bus pin on the aux connector. Flex and Kenwood radios output serial frequency data. Yaesu provides 4-bit BCD data. Pre-wired cables supporting many radios are available from Elecraft, or you may construct your own. Let's see the PowerCombo in action. Then we'll explore the KPA500 Amplifier, followed by the KAT500 tuner in gory detail. Here we have a PowerCombo connected in basic mode. In other words, only the keyline provides control. QSY from 40 meters to 15 meters. You hear the relays switch in both the amplifier and the tuner. Now let's go to 20 meters. Same thing. Different LCs are called, so there's a little bit different noise. Now let's go to 40. That's the PowerCombo in basic mode. Now that we've connected the aux cable between the K3 and the PowerCombo, we'll get instantaneous band changes before we transmit. Now we're on 40, 30, 20. Notice the antenna change. I have antenna 2 selected for the work bands. So when we go to 17, the KAT500 will switch to antenna 2. And back to antenna 1 when I go to 15. And likewise on 12 to antenna 2. And back to antenna 1 on 10 meters. 6 meters uses antenna 3. And in enhanced mode we can use the band switches on the amplifier to switch bands as well. K4 also interfaces in enhanced mode with the PowerCombo. Here we are on 15 meters. Let's QSY to 20. Both change frequencies immediately. So here we are on 20 meters. Everything's working fine. Let's go to 15. Both the tuner and the amplifier relays click, confirming that a band change has been made. And indeed, it has. We must configure the KPA500 for serial data. Go into the menu, and we select the radio entry, It's faster, since R is further down in the alphabet, to go up through the menu rather than down. We select Radio, Edit, Serial. Now we need to confirm the baud rate, so we go to RS-232X for transceiver and confirm that that's at 38,400. If we are using a very old Kenwood radio, we will need to use 4,800 bits per second. But for all modern Kenwoods and for flex radios, we want 38.4. Finally, we need to go to serial poll and turn serial poll on so that the radio will tell us its operating frequency. This is not necessary if we're using a logging program. Change bands and antenna. Change bands and antenna. Change band and antenna. And back. Your serial port through this IF232C adapter box. With the KPA500 configured to accept serial data, we can transmit, and everything's working fine. We change bands. The amplifier changes bands, but the tuner has to wait for RF. So there is the slight delay. It's a partial implementation on the very old serial Kenwood radios that don't support 38.4. To configure the KPA500 for Yaesu radios, we have to turn on what's called BCD mode, binary coded decimal mode, where it looks for band data in 4 bits of parallel data. Go into the menu, go to the radio menu, and select BCD. And we're already on 20 meters, so if we change to 15, there we are. So we XMIT here on. I'm discussing the KPA500 500 plus watt solid-state amplifier. The KPA500 is a self-contained 500 to 600 watt amplifier operating all modes from 160 through 6 meters. It is small and easily carried and works with all standard transceivers. The KPA500 is virtually silent, with its cooling fan off until the heat sink temperature requires it. Many protective circuits and a steel case make it rugged electrically and physically. All modes are supported with full power carriers for at least 5 minutes continuously. Full QSK is implemented with silent pin diodes. The amplifier was designed for remote operation, and it plugs into the AC power lines everywhere worldwide. Its power supply is linear, using a silicon steel toroidal power transformer for excellent efficiency and zero switching noise. The KPA500 is rated at 500 watts as a minimum. All production amplifiers easily exceed this power level, and most exceed 600 watts on most bands. It handles full carrier key-down times exceeding 5 minutes at a time. This includes FT8 with no time limit. Operators stepping up from barefoot transceivers are often astonished at the difference the extra 7 dB makes in their communications effectiveness. With its internal power supply and small size, the KPA500 travels with you. It is the same outline as the K3 transceiver and only weighs 26 pounds. Travelers appreciate the internal wattmeter, voltmeter, ammeter, thermometer, and other metering devices of the KPA500, since this means carrying less accessory gear, such as external wattmeters and their cables. The KPA500 is designed to work with all modern transceivers, completely hands-off. You don't need to touch anything during operation. With just a keyline cable and your coax, you're on the air in what we call basic mode. This uses an internal frequency counter that monitors your transmit frequency and, when necessary, changes bands in milliseconds. The drawback of basic mode is its requirement for a burst of RF for the counter to recognize a band change. This causes a slight delay, approximately 20 milliseconds, on the beginning of your first transmission after a band change. While this is transparent to many operators, it's completely eliminated by implementing enhanced mode. Enhanced mode is enabled by adding a data cable between your transceiver and the KPA500. With it, as soon as your radio QSYs, the amplifier follows without waiting for any RF. With enhanced mode in the Elecraft K3 or K4, the amplifier sings and dances. The K3 or K4 recognizes that the amplifier is in operate mode and automatically reduces drive power to the suitable level. Switching the amplifier to standby signals the K3 or K4 to return to its full output. Band changes from the transceiver are immediately registered by the amplifier. The band buttons on the KPA500 control the K3 or K4 as well, so you may change bands with a push of a button on the amplifier. Enhanced mode is enabled by adding an aux cable between the K3 or K4 and the KPA500. Enhanced mode cables for many other transceivers are available from Elecraft, including Flex, Kenwood, and Yaesu products, or you may build your own. The KPA500 accepts several types of frequency data from the various transceivers. For Elecraft rigs, the single-wire aux bus is used. 4-wire binary coded decimal BCD band data is accepted from Yaesu radios. ICOMs output a varying DC voltage that command band changes to the amplifier. Flex and Kenwood transceivers control the KPA500 via a serial data stream. The KPA500 is nearly silent. Solid-state TR switching means there's no mechanical relay noise as the KPA500 enters and leaves transmit mode. These pin diodes also allow high-speed QSK-CW operation. The internal cooling fan is off until the amplifier's heatsink temperature demands it. It may operate for quite a while, in a DX pileup for example, without any fan noise. The KPA500 is rugged. It's fully protected against electrical faults such as high reflected power, input overdrive, excessive heatsink temperature, and AC voltage variations. It's also physically rugged. Its mostly steel case is designed to be carried around the world. The KPA500 was designed for remote operation. Its rear panel serial port is active while the amplifier is powered down, allowing computer control at a remote site. Additionally, a hardware power control pin allows a digital voltage to turn the amplifier on and off remotely. KPA500 Remote, our free remote control utility program, is available from the Elecraft website. With it, you may monitor and control KPA500 operation from anywhere in the world. The KPA500 works from AC power outlets anywhere in the world. If your shack doesn't have 240 volts AC, you need not run a new power line to operate the amplifier. It's satisfied with 120 volts as well. It draws about 8 to 10 amps from a 120 volt line, about the same as a hairdryer, and half that from a 240 volt power line. Its power cable is detachable and uses a standard molded IEC plug, the same as on desktop computers. Wherever you are, you'll find a suitable power cable matching local power outlets. The power supply is a linear design using a large silicon steel to radial transformer. There's zero switch mode power supply noise from this linear supply. It's unregulated, so its efficiency is high, meaning less heat is generated inside the chassis. I will now discuss our KAT500 automatic antenna tuner. The KAT500, as we call it, was designed to match antennas presenting a 10-to-1 SWR to your amplifier at 600 watts. It features an integrated 3-position automatic antenna switch. The tuner memorizes previous successful tune settings, storing them by antenna position and frequency. While the tuner searches for a match, it bypasses your amplifier by opening its keyline. It also protects your amplifier from sudden antenna damage, for example, by opening the keyline when it no longer can produce a decent match. And the KAT500 works with all transceivers and amplifiers. A 10-to-1 SWR range is 5 ohms to 500 ohms. That's pretty much the limit of practicality for coax-fed antennas at 500 plus watts. The KAT500 employs an efficient L network for impedance matching, which is auto-reversing, depending on whether you're matching above 50 ohms or below 50 ohms. The L network components are top quality. The capacitors are premium RF current rated designs that are supremely rugged and reliable. The 3-position automatic antenna switch may be customized via our free KAT500 utility program to suit your station. For example, if your station has an external antenna switch for 80, 40, 20, 15, and 10 meters, plus another for 30, 17, and 12, and your 6-meter antenna comes in separately, you could set up your KAT500 so that the antenna 1 position connects the 80 through 10 meter antennas, antenna 2 connects the work antennas, and antenna 3 is dedicated for 6 meters. Or you could have multi-band antennas on each jack, or anything in between. You may configure it optimally for your station. If you allow multiple antenna positions for a given band, the tuner is smart enough to store separate tune solutions for the same frequency segment on each individual antenna port. The KAT500 offers 3.5 operating modes. The first mode, fully automatic, is intended for unattended remote stations. The tuner operates autonomously. It recalls the tune settings stored in memory, but if the settings are missing, or if the antenna no longer matches those settings, a new tune cycle will begin automatically. This has the side effect of occasional unexpected retunes while you operate. During this tune cycle, you're operating at reduced power, and retunes using single sideband mode take longer than those with full carrier modes. The standard operating mode for the KAT500 is labeled MAN. Unexpected tunes do not occur in MAN mode. You train the tuner on your preferred operating frequencies, and as you return to them, the tuner quickly recalls them from memory. Bypass mode turns the KAT500 into a 3-position automatic antenna switch, bypassing the ladder network. Now, what's that half mode? Well, when the tuner is powered off, the input is connected to the antenna 1 position. Each band is broken up into multiple band segments. The tuner stores successful tune solutions by antenna position and band segment. On 80 meters, for instance, you have a very different impedance at 3500 than you do at 3800. Since the KAT500 knows your transmit frequency and which antenna port you've selected, it recalls the correct match automatically. For this to work correctly, you must train your tuner by performing an automatic tune in each segment where you operate. Now the tuner is trained, and the next time you return to that frequency or segment, it provides the right match. Protection is another important feature of an automatic tuner. During tune cycles, a relay opens, interrupting the amplifier keyline and placing the amplifier into its pass-through or receive mode. You don't want to be transmitting at high power until a bank of switching relays, after all. The KAT500 also has a programmable maximum SWR threshold, where if the tuner cannot find an equal or better match, it will open the keyline to protect the amplifier. And the tuner protects itself by detecting if the antenna mismatch is too high for the output power. The KAT500 was designed to be operated remotely. Each operating condition and parameter is accessible via the serial port. Elecraft offers free remote control software, so you may operate your tuner via that serial port from anywhere. The software is available from the Elecraft website. The KAT500 has several other interesting features. In a multiple transmitter station, it will not start a false retune if it detects reverse power from a different transmitter. For example, if you're at field day operating on 20 meters and another nearby station is transmitting on 40 meters, some power, sometimes several watts of power, will travel up your coax and appear as reflected power on your SWR bridge. Many other automatic tuners will see this reverse power and switch into retune mode. On your next transmission, instead of seeing a matched antenna, your transmitter instead is met with a tuner frantically attempting to get back to where it started from. This drops your output considerably and is extremely annoying to say the least. The KAT500 doesn't make this mistake. In the standard MAN mode, tunes don't begin until you manually press the tune button. If you're using the full auto mode, KAT500 logic ignores reflected power readings when they are higher than forward power, preventing this problem. AH4 transmitter control, popular with many mobile radios and useful for station automation purposes, is supported with a rear panel jack. KAT500 runs from a standard 12-volt supply and generally uses less than 1 amp. It varies a little bit depending on how many relays are selected. The internal antenna switch is programmable via KAT500 Utility, which is available free from the Elecraft website. You may lock out unused positions or limit any band to 1, 2, or all 3 positions. The KAT500 was designed to work with the KPA500, but is universally applicable, working with all transceivers and amplifiers. It has the same outline as the KPA500 and K3 and is only 1.5 inches high. The case is made of steel, and 4 metal standoffs that reach from the top to the bottom cover are located precisely where the KPA500 feet are located, allowing the much heavier KPA500 amplifier to sit on top of the tuner and hold it in place. This is especially useful when you have 3 or 4 RG8 size coax cables hooked to the tuner. If I didn't say it clearly before, the KAT500 works with all amateur HF amplifiers. What we call basic mode relies on the internal frequency counter to save and recall tune settings into the correct band segment. Basic mode requires no data connection to the driving transceiver at all. The frequency counter runs all the time. When it detects that your transmit frequency has changed, it signals the tuner to select new inductors and capacitors as appropriate. This takes a short amount of time to implement, but only on your first transmission in a new segment. Let's look at the KAT500 operating in basic mode so you get a feel for the amount of time this takes. For example, here we are at the bottom of 40. Everything's working fine. We QSY to the high in the phone band, and the amplifier doesn't have to switch, but the tuner has to find new settings. And so there is a slight delay. While that wasn't very long, if you implement enhanced mode and inform the tuner that you've QSY'd before you transmit, there's no delay at all. Different manufacturers use different frequency reporting techniques. The KAT500 supports data from Elecraft K3, K3S, and K4 via the aux bus pin on the aux connector. Flex and Kenwood radios output serial frequency data. Yaesu provides 4-bit BCD data. Pre-wired cables supporting many radios are available from Elecraft, or you may construct your own. I hope you found this description useful. If you have any questions, tune into our live stream or contact Elecraft at our website www.elecraft.com, or email support@elecraft.com, or via telephone during normal business hours 831-763-4211. Thank you for listening.